All right, in 8.2 we're going to formalize a theorem that we've been using all year, which is Pythagorean theorem. You probably first saw it back in your middle school years, and we've been using it earlier this year, and now we're going to prove it and kind of formalize it. So first thing we're going to do is we're going to prove it. So if I look at this setup, we've got our right triangle with an altitude to the hypotenuse, the same type of setup that we've had in the last day worth of problems, last 2 days of problems. All right, so first thing I notice is I've got AC squared and BC squared. All right, so if I look at AC, I know AC equals the square root of AD, the section under it, times AB, the full length. All right, so I'm going to square both sides of that, and I get AC squared equals AD times AB. Now I'm going to do the same thing with BC. So BC equals the square root of BD times AB. Square both sides, BC squared equals BD times AB. All right, next thing I'm going to do is I'm going to add these two equations together. So when I do that, I get AC squared plus BC squared equals AD times AB plus BD times AB. All right, now when I look at this, I've got an AB in both of those, so I'm going to factor AB out, and I'm left with AD plus DB. All right, but if I look to my picture, if I add AD, this piece, and BD, this piece, don't I get the full length of the hypotenuse? So I'm going to actually replace that, and I'm going to write it as just AB instead of the two pieces added together. Now at that point I have AB squared. All right, so I have AC squared plus BC squared equals AB squared. And the way we usually do that is leg 1 squared plus leg 2 squared equals hypotenuse squared. All right, this is another rule that only works with right triangles, but it's really handy to find missing sides of triangles. All right, so if we're going to apply this, this should be a quick one for you. We just always want to remember to keep the hypotenuse out by itself. Hypotenuse is always opposite the right angle. So if I look at this first one, I've got x squared equals 15 squared plus 20 squared. All right, and now is when we get into like a lot of calculator work until we find a way to reduce this and do it on kind of a smaller scale and then scale it back up. All right, so 15 squared is 225. 20 squared is 400. All right, x squared is x squared, so I have x squared equals 625, and the square root of that, x, is 25. All right, so Pythagorean theorem. If I go to the next one, I've got leg squared, so y squared plus leg squared, 16 squared, equals 24 squared. All right, so y squared plus, and if I take 16 times 16, I get 16 times 16, I get 256, and then 24 squared, I get 576. If I subtract the 256 off, I get 320. So y squared equals 320. And then we take the square root of both sides. All right, and to find y, we're going to have to go off here to the side, 320. 2 goes in there 160 times. 2 goes in there 80 times. 2 goes in there 40. 2 goes in there 20. 2 goes in there 10. 2 goes in there 5. 1, 2, 3 pairs of 2s. So that's 2 times 2 times 2, which is 8. And then root 5. Yeah, y equals root 5. All right, now if we go to the last one, same setup. So z squared plus 30 squared equals 35 squared. And at this point, we've got z squared equals, I'm going to have to do 35 squared minus 30 squared, which is going to be 325. All right, if I take the square root of both sides, to clean that up, we're going to end up with 5 root 13. All right, and I'll leave that part to you, all right, as far as verifying that that does get to 5 root 13. All right, so that's a quick little review of Pythagorean theorem. I'm going to give you a way to reduce those triangles here in the next video. Thanks.